Greetings dear children, welcome to the academic year 2020-21 and I welcome you all to 7th standard. I hope you're all doing well and taking good care of yourselves. As you're all aware of the prevailing situation all over the world, we all must adapt ourselves to this mode of learning called online learning. I am Usha and I'll be taking up mathematics for you all. Let's take a moment and pray to Lord Vigneshwara to remove all obstacles in our learning path and make it enjoyable. Close your eyes and recite Vakratunda Mahakaya along with me. Vakratunda Mahakaya Suryakoti Samaprabha Nirvignam Kuru Me Deva Sarvakaryeshu Sarvada. Welcome back. We shall be starting our lessons with the topic from arithmetic. Let's recall the numbers that you have studied in your lower classes. To begin with, we start with natural numbers. Children, you all remember how to write natural numbers? If I write it in the form of a set, then I represent that set of natural numbers with capital N. And since I am calling it a set, I enclose within flower brackets. Okay, so you might have guessed already what the natural numbers are, and I'm sure you've all started writing in your notebook. So 1, 2, 3, 4, etc. All these are natural numbers. So 1 is the smallest natural number. Now, a step further if you go, we also learned set of whole numbers represented by the capital letter W, and the elements are, yes, can you tell me which is the smallest whole number? 0, 1, 2, 3, 4, 5 and so on. That is, a set of whole numbers also contains set of natural numbers. The only difference is 0 does not belong to natural numbers. So, the smallest natural number is 1 and the smallest whole number is 0. If you have noticed, I have written these dots. They represent infinity or countless or endless, unlimited numbers. And the symbol for infinity, if you all remember, that is the symbol for infinity. You have learnt in your 6th standard. Okay, now we move on. The next type of numbers that you all learnt in 6th standard is, I'm sure many of you must have guessed already. So, that set, I'll give a small hint, that set contains whole numbers and negatives of all the natural numbers. I repeat, the set we are talking about next is, it comprises of whole numbers and negatives of all the natural numbers. Yes, you must have guessed by now, we are talking about set of integers. And the topic that we are going to start is integers. This will be your first chapter in 7th standard. Integers. We are going to start integers. Already you have some knowledge about integers, Let's continue with that. Now, please write the set of integers. All the whole numbers 0, 1, 2, 3, 4, etc. Close the bracket. On the negative side, minus 1, minus 2. You can also call them negative 1, negative 2, negative 3, negative 4, and so on. Again, I repeat, integers, a set of integers, is a large set comprising of whole numbers and negative of all the natural numbers. Negatives of all the natural numbers. That is, all these numbers are positive integers. All these are negative integers. Then what about 0? Yes, as you all have guessed, 0 is neutral. It's neither positive nor negative. It is neutral. This is neutral. No sign. I'm sure you all remembered this. All these are natural numbers or counting numbers or positive integers. That is, to your right, to the right of 0, I have all the positive integers starting from 1, then 2, 3, 4, etc. to infinity. That is, 1 or positive 1 is the smallest positive number, positive integer. On your left, to the left of 0 or towards your left, all the numbers starting from negative 1, they are all called negative integers. These are all called negative integers. These are all called positive integers. As you all can see, 1 is the smallest positive integer, but negative 1 is the largest negative integer. I repeat, 1 is the smallest positive integer, but negative 1 is the largest or the greatest negative integer. What do we mean by that? I'll talk to you just after a bit. Now, if you have noticed, I've written all the integers as whole or complete. Nowhere I have written parts. What do we mean by that? I'll show you now. The integers, that is 4, 1, 0, negative 6, 100, negative 990, and so on. Such numbers belong to set of integers. Please look at this symbol. This symbol reads as belongs to. This symbol reads as belongs to. Just like we have equal to, not equal to. Similarly, we have one more symbol. I think already we have mentioned in the previous class. This is the symbol for belongs to. It's like the letter E, small letter E. What do we mean by that? 4, 1, 0, negative 6, 100, negative 990, all these numbers or all these integers belong to set of integers. Whereas, look at 0 and 1 or 1 and 2 or 0 and negative 1. Between these integers, we have what are they? Example, half minus 1/4 on the negative side, 3 by negative 13, 0.1, negative 5.6, and so on. All these integers do not belong to set of integers. I repeat, children, these integers which are complete or whole, they all belong to set of integers, whereas half, negative 1/4, all these integers which are not complete but which are parts, they all do not belong to set of integers. This symbol reads as does not belong to. That slash what you have written here, not equal to, this means does not belong to. Half does not belong to set of integers. 0.1 does not belong to set of integers. Therefore, half, negative 4, negative 1/4, 3 by negative 13, all these which are parts, not complete, they all do not belong to set of integers. Did you all understand? Okay. Now, if you noticed, certain numbers have not attached any sign. What does it mean? If I write this number 4, what we are actually meaning is positive 4. So, all positive numbers, you may or may not attach the sign. If no sign is attached with an integer, then it's understood or taken for granted that all these integers are positive. But whenever we say negative, suppose you want to represent a negative number, and if you write simply say 7, then 7 can be mistaken for, it will be understood as positive integer because you have not attached a sign. If you write it as 7, then we understand it as positive 7. But if you want to represent negative 7, then attach the sign negative. Did you all understand? So, we all understood what integer, set of integers is. Okay, now let us go a step further and let's learn how to compare integers. Even this you have learned in your previous year. So let's recall. Now children, this symbol, will you all remember? This symbol means belongs to. This symbol represents does not belong to. Belongs to, does not belong to. If you are talking about a single integer, then we say 1 does not belong to. If you are meaning a group, say half these integers, then you say do not belong to. Half does not belong to. All these do not belong to. Did you all understand? Now, quickly let us draw a number line. Children, you all remember how to draw a number line? Yes, I'm sure you all remember. Please draw a straight line. Use your scale or ruler. Draw a number line. And since we mean number line, a line is always shown with two arrows at the two ends, meaning this line can be extended indefinitely. A line, whether it is straight or curved, can be extended indefinitely. Okay, now on this number line, quickly represent both positive as well as negative numbers or negative integers along with 0. Start doing as I do. You also please start representing. Remember children, the spacing you can take it as 1 centimeter between the integers. So 0, which is neutral, is at the center. Towards my right, towards your right, we have all the positive integers. Clear? Use your ruler to show the gap of 1 centimeter. Okay? Now, start marking the integers. Okay? Towards my right, which is the smallest positive integer, now you all know 1, 2, 3, 4, 5, 6, 7 and so on. Infinite positive integers. It doesn't end with 7. You can get 8, 9, any number. On the negative side, which is the greatest negative integer, yes, it's -1. Then you have -2, -3, -4. You can even call it minus. -1, -2, -3, anything is okay. -6, -7, -8. Okay. So I have this much space, so I've stopped at 7 and this side at 8. If you have still space left, you can continue, say 9, 10, any number, because this is also infinite. Positive integers are also infinite. Okay children? Now, you all remember the rule, don't you? In your previous class, you learned a condition that as you move away from 0 towards your right, the value of the integers, positive integers, keeps on increasing. Value increases, becomes greater and greater and greater. How do we show it? Just see. Just to show you. If you want, you can, or if you don't want, you don't have to. What have I done here? I am showing as if we are climbing steps, ascending steps. It means that as you move away from 0 towards your right, the value increases. Please make a note. Value increases. On the other hand, on your negative side, as we are moving away from 0 farther and farther, see what happens. What has happened? Here, the value, here we are descending the steps. We are coming down the steps. So, value decreases. Clear children? As you move away from 0 towards your positive side, the value increases. As you move away from 0 towards your left, the value keeps on decreasing. The integers become smaller and smaller in their value. See how I am representing this. Okay. Example. 1 is less than 2 is less than 3 is less than, say, 50 is. So what is happening? The greater the positive integer, greater is its value, and so on. Whereas on your left hand side, -1 is greater than -2 is greater than -3 is greater than, say, -500 is greater than, say, 10,000, and so on. You see what is happening here? As you are moving away from 0, the value is becoming smaller and smaller and smaller. Then what about 0? 0, children, is smaller than all the positive integers. I repeat, 0 is less than all the positive integers, but 0 is greater than all the negative integers. Is it clear, children? 0, which is neutral, is lesser. It's less in value compared to all the positive integers, but it is greater than all the negative integers. I'm sure till now, till this point, you understood. I'll be giving you assignment or homework. In that I can give you certain examples, or if you have followed, that's fine. Next, we move on to what is known as absolute value. Absolute value of an integer. What is absolute value of an integer? This absolute value symbol is 2 vertical lines, children. 2 vertical lines, it's read as absolute value of. For example, absolute value of, say, 25. Absolute value of -25. Okay, let's see what it is. Now look at this number line. On the number line, if I have to write the absolute value, if I have to understand the absolute value of 25, what I do is, starting from 0, I move towards, say, after 7, 8, 9, 10, etc., you reach 25. Clear? On the left hand side also, you reach -25. How? To reach 25, starting from 0, you take how many steps? One step at a time, one integer at a time. Can you tell me? 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. How many steps I took? 25. Okay, now look at the negative side. To reach -25, again I am taking how many steps? 1, 2, 3, 4, 5, 6, 7, and so on. How many steps? 25 steps. Towards my right, when I reached 25, positive 25, we took 25 steps. To reach -25, towards your left, again you took 25 steps. So, absolute value of any integer, whether it is positive or negative, it's the number of steps you take to reach that integer. To reach positive 25, we took 25 steps. To reach negative 25, we took 25 steps. In both the cases, you all can see the absolute value is positive only. Then what about absolute value of 0? Absolute value of 0 is 0. What is absolute value of, say, 79? It is 79. Did you all understand, children? So absolute value, why are we learning this? So when we are learning fundamental operations, this absolute knowledge of absolute value comes handy. How do we read this? The two vertical lines represent absolute value. Absolute value of 25 is 25. Absolute value of negative 25 is 25. Did you understand? Please make a note. Next, we move on to addition of integers. That is, addition of integers on a number line and without number line. Okay? Addition of positive integers. Now, did you all make a note of this, children? Let's quickly move on to addition of positive integers. Now, for addition of positive integers, last year you have learned simple examples, that is with using a number line as well as without a number line. Okay? Now, let's see. Draw a number line. Let me show you with a simple example. Let us take 4, sum of 4 and 3. Okay? Draw a number line quickly. On the number line, draw the number line. We are going to add 4 and 3, which are both positive on the number line. Now, since I am adding only positive integers, I don't require many negative integers, but I will represent the negativity also to show that a number line contains both positive and negative integers along with 0. Clear? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now, I hope you're all ready with the number line. Look at 4. This is positive. So, from 0, I go 4 steps towards my right. This arrow is very important. It shows which direction you are moving. We are moving towards positive sign. So, I have written 4. Here, I write 4. Always from 0, children. Now, where are you? You are at 4. Now, you add 3, another positive number. So, 1, 2, 3. So, here I can write plus 3. Where did you land? You are at 7. So, how do we write? 4 plus 3 is 7. This is simple. You have learned this in your lower classes. Okay. Now, for addition of integers, if they are small numbers, it's easy to draw a number line and represent the integers. But it's not always practical for very large integers. Okay. Let me show you. Say 99 plus 80. Both are positive. Okay. Both these are positive integers. Can I represent all these integers on the number line? It's not practical. So what do? We recall the rule. What does the rule say? When you add 2 or more positive integers, your answer is positive. What do we do here? The operation is addition. So, sum of two or more positive integers is always positive because we keep moving only towards the positive side. Now, what is the answer here? 9 and 17. 179 positive. Is it clear, children? This means positive integers with or without sign. It means positive. If you don't write any sign, it means positive. Okay. So, this way we can do many more, sum of many more larger positive integers. You can try it in your books. I have one positive integer, one more positive integer, one more positive integer. Will you try? Yes, I am sure by now you would have written. Please insert the positive sign such as 154 plus 70 plus 200. What did you get? What have you done? You have added all positive integers. So what is the sum? 0. You have 4. You have 7 plus 5, 12. And you have 1. This is 2 and 2, 4. 424, that is positive. That means when you add two or more positive integers, sum is positive. That is rule number 1. Let us see what happens to negative integers. Next we talk about addition of, all this you have done in your 6th standard, children. Please recall addition of negative integers. Okay. When you are doing negative integers, so what you will do if it is on a number line, let us take simple example -3, and to this -3 let us add -5. Okay, draw the number line, children. Use ruler. See that the spacing is good. Now all are negative integers, so just one or two positive integers. Are you all doing along with me? So 0, -1, -2, -3, -4, -5, -6, -7, -8, and so on. Okay. Now, how do I represent this operation? What do? We have to add -3 and -5. See how I am going about. Now first integer is -3. From 0, now which direction do we move? We move to the negative sign. Okay, 0 to 3. Arrow, children, -3. To this -3, we have to add few more negative integers, which is that -5. So 1, 2, 3, 4, 5. On the negative side, how do we write? Plus or minus. So what have we done? To -3, we have added -5. Two negative integers we have added. What is the answer? You can see that the answer is also negative. What do we mean by that? When we add two or more negative integers, imagine the number line, let it be permanently fixed in your minds. When you add two or more negative integers, the sum is negative. How do we write this? Therefore, -3 plus of -5 plus of minus. This of means multiplication. We will come to that later. Now read it as sum of two negative integers. What answer did you get? You got -8. Again, it's not practical for large numbers. So let me show you one more example. Let us say we are adding -80 plus of minus 100 plus of minus 500. Yes, children, can you tell me? These are all negative numbers, so we are still going to add because all are negative. All are negative numbers, all are positive numbers. We call them like signs, same signs. Okay, so 500 plus 600, imagine on the number line. First negative 80, then I go still further, add another 100, then add another 500. So how much? Negative 680. Did you understand? Like that, even if we can also do many more negative integers. So remember, sum of two or more positive integers is positive. Rule 1. Make a note. Rule 1. Sum of two or more positive integers is positive. So all have positive signs, we add. Rule 2. Sum of two or more negative integers is negative. Clear, children? These are the two rules. Please remember. Now a small homework for you. Exercise 1. A simple homework. Okay. First one. Find the absolute value of minus 11 minus 201 99,000. Please find the absolute value of these. Second main. Find the sum of 906 plus 1260, that is 1260 plus 601. One more. Minus 850 plus of, children, you know how to read this? Plus of, because we have two signs together. 600 plus negative 523. So this is your homework. Please make a note in your notebooks. Solve them and we shall discuss all this again, all the answers in our next class.